The ultimate goal of today's tutorial is to teach you the skills and techniques required to be able to solder your circuits properly. Today we've soldered a Colpitts oscillator. On this side of the board are the components. You have the transistor, 2 resistors, a crystal 27 MHz, a capacitor, a jumper wire, and 2 connectors. The jumper wire is the blue wire. On the other side of the board, as you can see here, the blue wire. Then you have the 2 other connectors. This top one here is for the power supply, and the one at the bottom is for the input signal. A Colpitts oscillator is a basic building block for transmitters. Today we're using 27 MHz crystal. We can use other crystals subsequently, but this is the beginning of other series we're going to do with Colpitts oscillators. So why don't we just jump right into the soldering techniques. Hello everyone, welcome to our video tutorial on soldering techniques. So for this, quickly, you're gonna need a board to hold your components. You're gonna need a soldering iron. This one is about 25 watts soldering iron. A soldering station. I have this mini soldering station from eBay for $35. Then the components you want to solder up. In this case, we just have about 4 components, actually 5 components to solder up, and then you need a lead, soldering lead. Other things you might need is magnifying glass. Maybe this type will be good enough, or this handheld version. If you are soldering tiny components, you probably need some cutting tool. Could be a scissors, or maybe some form of cutter. Even nail cutter can do, to trim off the excess leads when you solder up your components, right? And again, I cannot emphasize this much, you need the circuit diagram that you want to solder. So the transistor, we're going to put it in place. Our circuit is basically a very simple circuit diagram. I'll show the circuit later, so maybe look at the corner of the screen as we're going along. The circuits will be popping up that we're trying to solder in place. So I'm just gonna put the component through this board, and the leads will appear on the other side. So this transistor is an NPN transistor, 2N2222. So I have it in place, and the leads appear on the other side. So I'm gonna solder it down. But sometimes it's better to have all your components lined up before you start soldering, right? So I have this lined up. I'm going to connect the base to the collector through a 47 kilo ohm resistor. I'm going to make a video on how to know the resistor values from their color codes. So expect that video in next weekend, alright? So this is a resistor. I'm going to connect it from the emitter, from the base to the collector side. So this transistor is, the terminals are labeled emitter from the leftmost. If the number is facing you, it's going to be emitter, base, collector. Emitter, base, collector. You can look it up on the internet. I'm going to show the image of the pinout also on in this video. So it's emitter, base, collector. So what I'm gonna do now is connect the resistor from the base to the collector. So remember, it is emitter, base, collector. So I'm gonna go from the middle of the transistor to the end. I'm gonna push the component in. Right. So I wish I could make it lie flat. So for that reason, I'm gonna stretch out the leg of the transistor a little bit more. So first of all, I'm gonna lay the resistor so I can get it flat on the board. I want to get it flat on the board. So I lay it flat on the board. Then I can bend the pins opposite directions, one up, the other down. It's so tiny, you barely see it. Then I'm gonna stretch my transistor terminals to see if I can match those two. I don't want to use extra. No, it's hard to match. It's hard to match. I can't match it because if I do, I'm probably gonna break my transistor. So instead, I'm gonna reduce the span of my resistor and see if I can match it right now. Again, there's no reason I'm trying to match it. It's just that I don't want to have extra lights, extra connectors. I want to have the components connected directly to themselves. So I have the transistor in place right now. Okay, so I'm gonna bend the pins. So again, this video is supposed to be about soldering techniques, not really good component layering, but they are part and parcel of the same, two sides of the same coin. You need to know how to layer your components because that will affect how you do your soldering. Okay, I have my resistor in place. I need to make the pins go opposite directions, otherwise they're gonna fall off, so they can hold on the board while I do other things. I need one more component between these two terminals, and I need another component from the emitter to the collector of the transistor. I'm gonna put a capacitor from the emitter to the collector, so it's gonna span the full length, right? So I'm pushing it in. I like to face the numbers outwards. The labels on the components, I like to face them outwards. Reason, so if I want to check if something is wrong, if I use the wrong part, it will be easy to view. So I'm gonna just push the capacitor in a little bit, and okay. Then I'm just gonna bend the pins. Then I have two more components. So I have 3 in. I need 2 more. I have this 1 kilo ohm resistor. I'm gonna connect the 1 kilo ohm resistor from the collector circuit to my power supply. So I'm just gonna lay it out wherever it ends, so be it. So I'm going to put the resistor down. I want everything to be flat in this circuit. Again, I'm doing this in the middle of the circuit, in the middle of the board. There's no reason for that. I could do it at the corner, but you know, this is just for experiment. You can do it at the corner so you can reuse the board for other things. But right now, we're not interested in reusing this board. We just want to show how to solder, right? And the last component is this crystal. So we're building a Colpitts oscillator, so we're going to use a crystal. It might not be this crystal. I'm trying to use a pin, what's it called, a connector, a socket connector, so we can plug in the different crystals for our experiment. But now I have the components laid out, so the next thing is to hook it up. Now you see why you need a soldering station, so it can be stable while we do our soldering. So you get your soldering iron. You need, I'm going to use a sandpaper, but you need a stripper, solder stripper, something to thin or to clean, I should say, the bits of your soldering iron. So you can use sandpaper, or you can use file. You're not trying to reduce the size of your soldering bit. You're just trying to remove any dirt. So it will be plugged in and heated. So you can use knife as well to clean it. Whatever you have, just use it to clean the bit of your soldering iron. So I've used all 3 right now. I've used the knife, I've used the file. You can use the scissors if you have a scissors, whatever you have to clean the tip or if you have sandpaper, just lightly use it to clean it. And then if you have a lead thinner, you can add it, but if you don't have, if you have an alloy lead, you should be fine. Get your lead and make the bits of your soldering iron a little bit wet. Okay, and you're good to go. There's smoke coming out, so make sure you don't inhale it. Alright, so we're gonna apply the soldering iron at an angle and apply the lead at another angle and very close to the terminals you want to solder. So you have two components together. You first of all apply the soldering iron so you can preheat the terminals, and when you apply the solder from the other angle, it's done, right? So you're going to repeat that for all the terminals. Remember, we already layered the components, so repeat the same and repeat the same, and on and on and on. Doesn't matter how many connections you have, just use the same principle. And what is this principle? You lay down the components like we've done, and you align the contacts that you want to be soldered together. Keep them close to each other, and then you start applying your soldering iron. First of all, apply the soldering iron, preheat the contact, and then apply your lead from the other angle, and you're done. You get a very smooth soldering. If the contact is preheated, you get a very smooth soldering. When you're done, put your soldering iron back into the solder station. Then you can remove the board and inspect the contacts. Alright, so do your inspection. You can use a magnifying glass for that. For this station, you can use this magnifying glass. The light makes it a little invisible for you, so I'm gonna use this handheld magnifying glass for the camera. So inspect the contacts and they all look great. So I'm gonna just do one more inspection. This is great, right? Very, very awesome. So I'm gonna try to turn off the light from the soldering station and see if it's a little bit clearer for you. Alright, the contacts are perfect. We don't have pillow heads. Pillow heads are caused by uneven heating and cooling. Right, so I'm gonna plug it back, turn it on one more time. Alright, so I'm gonna check visually to see this resistor. I did not solder it, so I gotta put it back in. This resistor and transistor joins together. I didn't solder that, and then they will also join the other parts of the circuit. Your soldering should represent your circuit diagram. Okay, if you missed any soldering point, just like we did, you go back, apply the same principle. Heat from one side, so preheat the terminals, and then apply the lead from the other side. So if the terminal is able to melt your lead, that means it's properly heated. Okay. If you have very thick terminals, you might have to preheat it a little bit longer. And then once you're done, it's time to trim off the excess. You get your preferred trimming tool. It could be something as simple as nail clipper, doesn't matter. All you need to do is to remove the excess leads. Okay, so I'm removing the leads. Let's make sure it's in view so you can see what we are doing here. So I'm going to lift up the terminals and then just snip it off. That's what you do, right? And I'm going to do proper cleaning you don't want any floating LEDs or leads. Sorry, you don't want any floating leads and LEDs as well. Now, if you're building an RF circuit, which is what we are building here, you want to have the shortest leads, right? You want to have the shortest leads as possible, because longer leads could introduce stray capacitance or inductance. And the capacitance and inductances, if you watched our video on FM transmitters and receivers, you will understand that capacitances and inductances are influenced by the length of the conductor in the circuit, right? Now, I really want this component to be very flat, so I'm melting the terminals again and pushing my component in, try to get it flat. Again, no particular reason for this, it's just choice. I like when I'm done with soldering, it looks very beautiful. Okay, if you think there's some areas that need some touch up, you do the touch up. Start by melting the existing leads and then applying more. Right, so it's done. So let's recap on how to do soldering. You see, very simple. First of all, you must have a circuit diagram. It is a must. You must have a circuit diagram what you want to solder, unless you just want to do a trial. But even if you're doing a trial, you need to have at least two components or two terminals that you want to solder together. So have your circuit diagram, then have your soldering station. It doesn't have to be elegant or elaborate. You just need something to hold your board. You can hold it by hand. Actually, you can hold it this way and hold your LED, not LED, but your LED with the two fingers pointing down, and then you apply your soldering iron at an angle. This is the good old way to do it. You apply the soldering iron from one side of the terminal you want to solder, preheat that terminal, and then apply the lead from the other angle. It will achieve the same thing. But if your hand is shaking, if you're not used to this, get a cheap station, $35 from Amazon, and some of them have lighting like this. Some of them are cheaper, like under $20, under $15. They don't have the lighting. These have the lighting, the magnifying glass, two sets of magnifying glasses, and a rack to hold your components. If you want to get this type, so you can put some components here: resistors, capacitors, transistors, all kinds of components you can put in this station. And then you have a tray to hold maybe some scraps or things like that you cut off, you snip from your station, you can put them there. And you can also have a kind of so-called soldering cleaner. The soldering bit cleaner, you can have it in this place, so you can just use it to wipe it off. But then, if you don't have that, get a sandpaper. If you don't have that, get a file. If you don't have that, get a knife. If you don't have that, get a razor blade. Get anything that will help you. I'm gonna use tweezers as well. Get tweezers, whatever you have, just to clean the teeth. Apply the soldering iron at an angle to the terminals you want to solder. Apply your lead from the other side of the terminals. If the terminals can start melting your soldering iron, your soldering lead, sorry, then you know it's ready to go. Then you can apply more leads, right? First of all, wet the soldering bit, and then you start soldering. As simple as that. When you're done, snip off the excess leads and you're good to go. So this circuit is done. We're going to test it in a different video. Remember, we didn't solder in the crystal yet because we don't want to have it soldered in. We want to have it pluggable, right? But that's nothing wrong with soldering in one right now. So, but we're gonna keep that for now. You know what? Why don't we just solder in one? Okay, let's get one and solder it in. All right, so we have these crystals. So we're gonna use one of them, 27 megahertz crystal, and just gonna pop it in across the resistor. Let's give some gap. because we're gonna be desoldering it and using another one later. We've ordered some connectors for this purpose. They are yet to arrive. The socket, they're yet to arrive. So for now, we're just gonna solder in one and use it for the experiment, right? So for this, I'm gonna bend the board over and bend one of the terminals. So you always want to bend it towards the component, the connector or the point you want to solder it. Right? We have other components in already. So again, the rule of thumb is to make sure you wet the bit and then you apply the soldering iron first. Preheat the terminal and then apply your light from the other end. Make sure you don't overheat. Okay, some components are sensitive to heat. Make sure you don't overheat. If there's a possibility of overheating, consider using heat shield or something like that to protect your components. Or heat sink, sorry, something that can help to sink the heat so your component doesn't get overheated. Alright, so the circuit is complete. Now we just have to connect power supply and we can do our testing. So I'm going to connect 2 wires. I'm probably going to take some connections from this and just make our, yeah, why not? Oh, we can actually let's look for some other things to use. Yeah, I'm looking for a terminal, something to use like a pin connector so I can plug in the power. Okay. Alright, so to connect the terminals, we're gonna just connect from positive. So we're gonna use this wire to bring from the ground, which is the emitter circuit. This is a common emitter circuit. So from emitter to the 1 kilo ohm resistor, right? And then we're gonna use this pin connector so we can plug in the power supply here. I'm gonna use it here. And then for the input circuit, we're gonna connect another connector. The input circuit is the base and emitter will be the input. So this is a common emitter circuit. So the base of the transistor is right here where you have the 47 kilo ohm resistor, and the emitter is the ground. So we're just gonna put another connector right there. So we're gonna turn around and solder this. So this is a little bit tricky because they could fall off when we turn them over. So the secret is we're gonna do them one by one. So we're gonna take out one, and when we flip the board, we're gonna hold it this way. I'm gonna hold it with one finger so it doesn't fall off, and then I'll solder from the other end. So carefully watch what I'm gonna do. So the pin I want to solder in is here. So I'm gonna hold it, flip over, and I can hook it back, but it's gonna be tricky. So I'll hold it with my hand, apply lead to one of the terminals, and then I can release my hand. So you're gonna be very, very careful, extremely careful. The lead or the leads are very thick. So if you apply the heat, it could transfer easily. So you're gonna do this very fast. So I'm gonna apply the heat and then apply the lead. Let me wet it first. Yeah. Alright. Okay. It's not strong enough. I'm gonna try to push. Alright. It's hard to see with the lighting. Let me take it off and show you what we've done. Really difficult to see with the lighting we have here, but I have one of the terminals soldered. You can see the pin is staying, but it's not strong enough yet because we have to apply more lead. So I'm gonna solder the open connector, the open terminal. I'm gonna solder it properly first, and then I'm gonna go back and fix the other one. So I will join that to the 1 kilo ohm resistor. Okay, I have a suspicion the two terminals might be shorting, so I need to separate, make sure there's separation. So I melt the lead, not LED but the lead, and just push between them, make sure there's no connection. Alright, then I'm going to bend the connector from the other side. Again, I will show this full circuit diagram so you don't have to worry. But the techniques I'm trying to show here is sometimes you might solder and you have the pins short. So what do? You can desolder. So we're going to make another video on the soldering technique, but today we're going to concentrate on soldering. So just trying to bend the other pin, and then we're going to apply the solder, right? Apply it on this side, heat up one of the terminals, apply the lead. You notice I've been seeing a lot of LEDs today because I did another video on LED, and LED and LED, I kind of get them mixed up because I just finished shooting the video on LED. Alright, so you see the separation there. Okay. Okay. So I'm gonna solder the other end to ground. So bend it over. I'm bending it towards the ground. It's stretching a little bit over. So when you bend a pin and it's stretching over what you already soldered, you can trim it before you do this next soldering. So trim the excess, hook it back to our soldering station, and then we just have to apply our lead. The soldering trick again: heat up one side, apply the lead, and just make them flow together. This is one trick to avoid pillow heads. Pillow heads are uneven soldering, uneven cooling and heating and cooling. It could break off not long after. So you make sure that that doesn't happen. Now I'm gonna connect the other pin. Remember, we had two of them. One is for power supply and one is for signal. So this is for the signal. The input signal is going to go between the base circuit and the emitter circuit, which is right here. So we're going to use the same trick to solder it between the base and the emitter. Right. So we're going to use the same trick. Get one side. So I'm going to hold this by hand, because there will be those of you who do not have the soldering station yet. So you don't have to really have a soldering station to do this. Having a soldering station is good, but you don't have to have it. So I'm going to hold it by hand. You're going to have to endure the heat. Like, you got to endure the heat. It's very hot. So if you can't endure the heat, then make sure you have protective gears. I wet my bit and then just apply a little bit of lead on one terminal. Doesn't matter how small, just a little bit of lead will hold the pin in place. Then I'm gonna fix the one that is free flowing so you can hold it while I solder the next one. So now I'm gonna fix this one here. Alright. Now I'm gonna solder the next one. To the ground. I wonder if you can see this properly, but what I'm trying to do is to solder the two pins to ground. Right. So I've added additional lead, but I'm just gonna make both of them to flow together. Okay, I think they flow together now. I'm gonna try to supply external light to see if you light up and reveal exactly what we've done. Maybe at this point, yes. So I have the connector for the input circuit. Let's make it a little bit difficult. Okay, yeah. Now that's the focus. You have the crystal 47 kilo ohm resistor. So it is yellow, violet, and orange. 47 kilo ohms, and then 1 kilo ohm resistor that is brown, black, red. 1 kilo ohm. You have the power supply connector, and then you have the signal connector. Signal connector goes from the base and ground, base and emitter circuit. And then you have this capacitor going from collector to emitter, and that's it. So I'm going to try to fire this up. It's a Colpitts oscillator using a crystal, 27 megahertz crystal. So we're going to fire it up and test it in a different video. We're going to discuss this fully in another video, but the reason we're building this circuit is just to demonstrate soldering technique. You can see how clean the soldering is. These two pins here is the power supply pin. Soldering is clean. You have this long stretch which is connecting multiple components, connecting the capacitor, the transistor, two resistors, and the crystal on the collector rail of the transistor. And you have the other short runs. This looks like it's a bulging. The reason is because the input connector is on a different line than the other components, so we had to use the light to loop them together. So it made it look like it bulged, and then between that is the other terminal and ground. It's also long running because it starts with this wire taking from ground, and the only reason we put this wire is because we want to use pin for the positive terminal, right? We want to be able to plug it in and plug it out. We don't want to have wires running from this circuit. Just keeping it a little bit clean. Okay. So we're gonna yeah, I think I like this view a little bit better. You can see the components clearly. Alright. So again, thanks for tuning into my channel. Keep watching, and if you haven't subscribed, please subscribe. We'll be showing you things like this going forward. We're going to show you the soldering techniques, and we're going to build this is, of course, you know, once you talk about Colpitts oscillator, you're talking about a transmitter. So this is already a shortwave transmitter, if you will. We just need to modulate it. So we're going to be talking about this transmitter and how we can use it as an amateur enthusiast, you know, RF enthusiast. So you can use this as a basic building block for other circuits. Alright, thanks again, and keep coming back for more. And if you have questions, put it in the comment and we try to respond to it. Okay, I will see you all in my next video. Thanks again. Please subscribe, and if you've already done so, if you've already done so, please subscribe to my channel. And if you have already done so, thank you so much. Like, comment, keep coming back, and share with your friends. Let them know what you're learning from Hacker World. We go from the basic to the advanced. Alright, talk to you later.